Good afternoon. My name is Michael King. I'm with FDI, also known as Future Designs. I'm going to be talking today about GUI development using emWin on the FDI direct drive LCD platforms. At FDI, we are experts in both GUI development in general and in emWin. Our goal is to bridge the support available from Renesys and allow customers to quickly and easily get to production with an embedded GUI product. Here's a little bit about me. I'm a software engineer for Future Designs. I've been at FDI for about 2 years, and I've been a software engineer for about 5. And I work with Renesys on the RX and RL78 RDKs. In FDI, I provide a full-time dedicated technical resource for Renesys and Renesys customers. I have a background in object-oriented C++ and C#. Before FDI, I worked for several years in telecommunications as a software engineer. And I'm a bit of a software hobbyist, so I mentioned a few little extra things I do: web design, phone development, game development. I got a YouTube video on 3D planet generator design that got some popularity on YouTube. And here's some information about FDI. We're proud to be a Renesys Platinum Alliance partner. We work in conjunction with Renesys ecosystems and AE teams to design, test, and manufacture both of the high-volume RDKs being used at DEF CON this week, and that's the RL78 G14 and the RX63N RDKs, in addition to the other RDKs, the RX62N and the RL78 G13 RDK. And I've been responsible for writing software to test every aspect of these boards at the prototype level and during manufacturing. And FDI is a full-service embedded design and production firm specializing in touchscreen graphical user interfaces. We offer both full-featured touchscreen GUI development kits to get you started and cost-effective touchscreen GUI modules for volume production. We also do custom designs, work with existing hardware, and assist in the manufacturing process. And here's an overview about what we're going to be talking about today. I'm going to be going over a little bit into the software and hardware we'll be using and how to get the hardware. And then we're going to go over the steps that we take at FDI in creating a touchscreen GUI. And when I say this is we've had numerous projects in the past, even in the past years, 5 to 10 projects where we assisted someone in getting a GUI development into production. First off, Muse. Muse is a software kit that we developed at FDI for rapid development. And it abstracts the hardware level drivers and makes it easier to port across different processors and RTOSes. And I'm briefly mentioning this today because we'll be using Muse to develop our touchscreen GUI. My coworker Lyle Shields will be going into more details on it using an RX63N RDK tomorrow in his lecture, Rapid Development for the Renesys RX63N using Muse and FreeRTOS. And one of the decisions we have to make, the big conundrum, is how we're going to draw our graphics. We chose to go with Segger emWin because it's one of the most popular embedded graphics packages on the market. It has been around for a long time. It has a relatively small footprint. It is processor and LCD independent, and it doesn't require the use of any C++. And Segger is also a platinum partner with Renesys. And we have worked with them at FDI to become experts in their GUI software. And at my time at FDI, I've worked mainly with the RDKs, and some of my coworkers have some more expertise in emWin, so if I can't answer questions about emWin, I'd be happy to get you in touch with someone at Segger or someone at FDI who works with it much more than me. So direct drive. And I'd like to briefly touch on this because we're going to be using a direct drive kit today. And direct drive was developed by Renesys to allow us to drive the LCD display without using an LCD controller. And it's specifically on the RX series of processors. And it involves sending frame buffer data from the SDRAM directly to the LCD using the processor's DMA. It also synchronizes the processor timer unit to control the horizontal sync, the vertical sync, the data enable, and the dot clock. All right, now we're going to go over the hardware, where to get the hardware and software we'll be using today. Today we'll be using an FDI 4.7-inch direct drive development kit, which I have over here. It's under camera, so we'll switch over that in a minute. And this can be purchased from any of our franchise distributors. the kit allows us to swap out different processors and different LCDs depending on the application we're writing. It comes in 3 parts. On the right, we have our LCD board, which is connected to the peripheral carrier board in the middle, which has Ethernet, USB, and some other peripherals on it, serial communication. Then at the top, we have our processor SOMDIMM module. And today we're using an RX62N. And this also comes with an SD card slot. It has our SD RAM for our frame buffer and has a JTAG connection for debugging. And for software, we provide a Muse emWin template project available on SourceForge. We put updates to Muse every month or two. We're continuously updating the software packages. For an IDE, we're using the High Performance Embedded Workshop. And the projects we're using today in this lecture can be, we're putting up a link on our website, and you can download that and also get presentation information as well. And here's a breakdown of what a Muse project would look like when you download it from SourceForge. It comes in 3 parts. We have our Muse library, which is a DLL that's it's compiled separately. And that's going to contain all our device drivers. It's contained, today we're using FreeRTOS, so we'll have our RTOS that's compiled into this library, as well as our processor-specific drivers. We also have our platform, which is our hardware-specific setup. And that's going to set up it's going to route all our different pins for us. It's going to set up our SD card file system, as well as LCD and touchscreen drivers. And it's also going to get our direct drive up and running for us. All we're going to be concerned today is writing our windows and graphics. And if you'd like to take a look at look at just emWin, you can go to Segger.com and download the RX62N trial from their website. And this is going to contain the graphic DLL for the RX62N, and it has several tools: the bitmap converter tool, font converter tool, and the GUI simulator. I'm going to give you a quick little demonstration of the GUI simulator. Okay, this is a Microsoft Visual C++ program that acts like you're running emWin on the hardware, but instead displays it on the screen for you. You can design and write your windows, your emWin windows, and then drop them into this application directory on the right. And whenever you compile and run, it will show you what your GUI looks like that you just developed. And this is the emWin demo. They show off a few of their features. But this is great for if you want to do GUI development when hardware is not available, or if you're showing to a customer what the GUI is going to look like. And it also is great for exploring the emWin libraries. Yet, the emWin libraries are pretty powerful, but they have a GUI developer or a GUI builder, and I know a lot of systems are showcasing GUI developers right now. But we find it a lot more useful, and we get projects done through software. So this is how we would get started with a GUI development. And we've seen some of our customers also use the simulator as well. All right, today we'll be writing a simple picture frame application similar to an electronic picture frame, except it's going to be touchscreen. Our application will allow us to view bitmaps from the SD card and display them on the LCD. When the user taps the screen, we're going to show several buttons. We can navigate to the previous picture, we can navigate to the next picture, we can start and stop a slideshow mode. We're also going to have settings, so the pictures can have an album title, we can associate a time and date with it. Here's a few images of what the application will look like when we're done. Top left, we're displaying the image from the SD card. When the user taps the screen, we got our buttons. On the bottom, we have some of our settings, and we'll go into that in the third part of the lecture. Okay, now we can start writing our picture frame application. And we're going to start by displaying images from the SD card, and we'll stop there. before doing any more of the buttons and everything else. Before we can do this, we need to add our windows to the FDI GUI manager. The FDI GUI manager is provided with the template project. It starts emWin, it links our LCD, and starts our touchscreen tasks. And today we're mainly going to be concerned with adding our window routines to our create all active windows method in the FDI GUI manager. And once we do this, you can see we're adding it to this array, and this is already all set up. You just have to associate a new ID with it, home screen, settings screen, etc. Once we add our routines, the GUI manager also allows us to switch between the screens quickly. All right, to retrieve our image from the SD card, we're going to use some use routines. First, we're going to allocate some space for our image. We're going to set up a file name, and in this case, we're going to the OneDrive. Similar to how we have a C drive and D drive, we use numbers. It's going to be the OneDrive, and we're loading family pick 1. We're going to use the muse file open routine, and this is going to tell us that that file is out there. We're going to load in the image data using the muse file read routine, and then we're going to close it when we're done. To display the image, we're going to use the emWin GUI bitmap draw routine. In this case, we're displaying pointer to image, which we just loaded using the muse routines, and then we're going to display the image with an x coordinate of 0 and a y coordinate of 0. Now we're going to show this in action on the hardware. These windows are kind of tiny. Okay, here's similar to the routine we just looked at on the PowerPoint slide. And whenever I run this and download it to the hardware, we should see an image on the screen. Pull up the video. All right, there we go. We got our image at a Family Guy pick on the SD card. So. All right, the previous example showed us how to load and display a single image. But this is not going to work when we're trying to switch images quickly. We're trying to go to the next image or the previous image. We're going to want to switch, and we're loading the data from the SD card, and we don't want to wait on that. So the best way to do this is we have a load image task. We're using free RTOS, so we're going to use our RTOS to continuously load images based on where we're at that time. So we're going to have a previous, current, and next image loaded at all times. That way when we press the next button, it can go ahead and just change pointers around and show us the next one, and while we're looking at that image, it'll start loading the next image for us. Now we're going to move on to drawing some buttons and handling events. Here's what our navigation dialog is going to look like, and this is going to appear on top of our image. We're going to have a next button, a previous button, a slideshow start and stop button, a settings button, album name, and time and date. These are going to be done using widgets, and we're going to create it with the GUI create dialog box routine. And this uses the table, the GUI widget create info table above. And we can set up our different widgets using this table, and each line is going to have an ID for that widget, so we can retrieve it again. It's going to have a type, so we have 2 buttons here, 2 text fields here. It can have some text if you want to display text on the widget. And it's going to have XY coordinations for the location, and it's going to also have size. And everything is done as a box. So you're putting a location and size for every object you're putting on the screen. And here we have our GUI widget create info routine. And I've set up buttons that we've talked about. And I've called the GUI create dialog box routine in our picture frame main. Just recently. So when we download this onto the hardware, we should see this. Okay, you should see here now we have our buttons laid out on the bottom. We don't have graphics on them yet. We're going to do that next. But we just want to make sure we got them positioned correctly on the screen, and we have our settings button on the right over there, our album name and our time and date. I just put some generic text in there so we can make sure it's lined up correctly. We're going to change the font on those in a minute. I'd like to briefly touch on the emWin window manager because we're going to use it today to add our graphics. The emWin window manager provides features found in the standard user interface frameworks, allowing us to widgets to be created, moved, resized, and placed in subwindows. Additional features also include enabling, disabling Z positioning, and transparency. In our application, we'll be using the window manager get dialog item routine, and this is going to retrieve our button structure for us. And then we're going to use the button set bitmap routine, and this will link in an image for that button. And also, we're going to need to use the emWin bitmap converter tool to change our graphic, JPEG graphic, into a .c file. And we bring this into our project, and we can use the set bitmap routine to link that new object and apply it to our button. And the bitmap converter tool can be found with the emWin trial. And here I'm going to show you how we can convert this bitmap. And I've just loaded our next button. We're going to want to change this button to a best palette and transparency, and this is going to allow us to change the background of the image whenever the user has held their finger over it on the touchscreen display. It'll make our white background become transparent, and we can set the background of that button to be different things after that. We also have to set the background transparency color to be all Fs, and this is something that emWin will need. And then we save it. And here we're going to select the run length encoding 8, and this is not preferred for like pictures per se. It's better for graphics, and it's going to make it so that the graphics are going to be displayed quickly at runtime. And also compressed. So it takes up less space for us. And then that created a .c file for us, and I've taken the liberty of adding those into the project. And throwing them into the graphics buttons directory. And we got our forward button, pause button, and so forth. And I've also used the emWin routines to go out and retrieve our button and assign a bitmap to that button. As you can see here, we did it for all four buttons that need graphics. And now we can download and run that, and we should see some graphics. So now we have our graphics. Now it's time to add events to our buttons. When creating our navigation dialog box, we provided a dialog callback routine at that point. And this is a basic example of what this routine looks like. And this will be called each time an event happens inside our GUI, such as init dialog that's going to fire off when our window is created. This is where we just added our bitmaps to our button. We added our graphics to our buttons. The window manager notify parent event. This is especially important because this is when you push a button, this is the event that's going to occur. And we're going to have to take care of, at this point, we're going to have to take care of what we want to do. Before going too much further, I'd like to introduce a useful utility that we use at Future Designs that is provided in this project. After working on several different projects and doing user interfaces with emWin, we found ourselves doing much of the same steps in code over and over. emWin allows as a user to customize each and every trait of a dialog box, text box, or button, and it's certainly good, but in many cases, we just need to do the same steps over and over. To help with this, we create a look and feel utility, which standardizes how each widget is initialized and keeps the same look across the whole application. Additionally, instead of using large case statements to catch events for each component on a dialog, we use a look and feel table which can declare which routine will be called when the event occurs, such as I handle button at the bottom. I don't know if y'all can see that. That's a routine pointer, and whenever the ID button is pressed, that routine will be called automatically. And I went ahead and added events to all our buttons. Okay, now we're running. Okay, now when I press the next button, we're gonna change our image. There it is. And also the look and feel utility, we could apply our fonts. So we gave the album text at the bottom and the time and date at the bottom. We gave it larger font so you can read it a little bit better. So now it's time to move on to our settings screen, and this is where we're gonna where we can set our album name, and we can also assign time and date text. It's user input, and we provide we did a few of the input methods at FDI. It's similar to the keypads and keyboards you'll find on your phone. Whenever you press where it says family vacation text field, it will pull up a keyboard. And whenever you press the field that has a number on it, it's going to pull up a keypad for numeric entry. For the settings screen, we already went over how to do buttons and text, but I'd like to show you how to call up the keyboard. When the family vacation is actually a button with text assigned to it, when you press that button, we're going to call the keyboard routine. That keyboard is then going to be placed on top of our screen, on top of our GUI in the background, and we can enter in new text, and we can press enter or cancel, and it'll return our new text and put the text inside the GUI button. And here's a picture of what the keypad looks like, and it's called similarly. And this will, depending on the size of your LCD, this will all resize. And it can also be skinned. emWin allows you to have skinning methods to give it a more modern feel. Now we're going to take a second to see what that looks like on the hardware. I just moved my project from one folder to another, and it's trying to find all the files again. Okay. So now when we click on the settings button, our settings screen is going to appear. I can then press the album name button. Our keypad appears, and I can type in a new name. DevCon. When I press the X, this text will now appear at the top. Yeah, this will conclude the GUI development portion. And, obviously from a software perspective, not from a GUI builder perspective. But this, again, this is how we find with the tools that we have and what we have to work with. This is the easiest way to get these GUIs done and get a product into production. I'd like to take a second to show you all a couple of the kits we have. This is the kit we use today, but there's also a RX63 and SOMDIM module available. And we also, for LCDs, we can do other sizes, but right now we have a 4.3 and a 4.7 wide QVGA LCD carrier board. And there's some part numbers at the bottom. And then this kit specifically is more for development. Since it allows you to switch out your LCDs and switch out your processors. We have a 3.5 RX62N GUI board that is meant for more high volume orders. And its price model, the development kit starts at $299, but when we get into higher volume production, we can get it down to under $100. And this comes with an RX62N processor, a Tianma 3.5-inch display. It has SDCard, debugger connection, a speaker. And you can also bring out your, it has an expansion connector, so we're working with controls, industrial controls. You can bring your GPIOs out, and several different communication interfaces such as I2C and SPI can come off of this expansion connector. Ethernet and USB as well. Okay, today we talked a little bit about emWin, Muse, and how you can download our Muse emWin template projects and our source from SourceForge, and we allow that's open source. Anybody can download it. We talked about how to display images from an SD card, how to create buttons and text in emWin, and showed the FDI keyboard and keypad. And again, if you'd like to go and look at any of the project source that we talked about today, you can go to teamfdi.com/devcon 2012. So I hope you all come and see us. And thanks for being here.
Good job.
Yeah, thank you.